These are the supplemental notes for 11-10, regression model. Let's jump right into it.
For this lesson, we are going to determine an appropriate nonlinear model to use for a scenario. So first, we're going to be looking at different function types. So we have to choose whether something is linear, exponential, or quadratic. Linears create a line, exponential creates a curve, and quadratic creates a U, a parabola. Determining the regression equation. You're going to put the XY ordered pair into the regression calculator. You're going to press resize window to fit the data in order to see all the points. Then you're going to go to the drop-down menu and select the type of regression model you see. Remember, if it's a straight line, it's linear. If it's a curved, it's exponential. And if it's a U-shaped, then it's going to be a quadratic. This will give you the equation for the graph. Then what we can use is we can use that equation to make a prediction. So we will follow the steps up above. We will take that equation and round it to the nearest hundredth. And then we are going to use the model to make a prediction. We will substitute the value in for x and then solve. Then we can analyze a data set. There's extrapolation and interpolation data. Extrapolation is a prediction made outside the range of the value in the data set. Interpolation is within the range of the value. So examples. Remember that most of these examples come from the assignment portion of the lesson. So, which type of function best models the data shown in the scattered plot? Okay, so we have to look at it. We're going to look at the shape of the data. So is this a straight line? No. Is it a curve? No. Is it a U shape? Yes, it is a U shape, so this would be a quadratic. Complete the statement about the volume of a water storage tank over time as shown in the table by filling in the blank. So it says the data set in the table can best be described as blank because there is blank. All right, so we can look at this data set without putting it into the regression calculator and determine what type of data it is. So how am I increasing or decreasing here? Am I increasing by or decreasing by a constant rate of change that's linear? Or am I being multiplying by a constant number to get to the next number? That would be exponential. Or are there two values that create by the same x value to create a U shape? But we can put them into our regression calculator. So I can put these ordered pairs into my calculator. 1, 12, 2, 6.1, 3, 3, 1.6. Oh no, hold on. 4, 1.6, 5, and that's 0.8. Remember that you have to resize the data in order to fit. So you can see here, without looking at the line, this creates a curved shape. So we have to sit here, we have to change this to exponential. And that will show you that this creates a curved shape. So this will be an exponential function, and it has a constant multiplicative rate of change. Because we multiply by the same number. All right, so let's look at number 2 or 3. So it says the table below shows the approximate heights of a ball thrown up in the air after X seconds. Which quadratic model best represents the data? Okay, so let's go back to our regression calculator. We are going to clear the data and start putting in our new set of ordered pairs. So 0, 5, 1, 90, 2, 140, 3, 160, 4, 150. So it already told us that this is a quadratic model. So we're going to go here and we're going to hit quadratic and then make sure that we resize to fit the data. So then it gives us our equation right here. Obviously we have to round though. So this, if we round up, this rounds up to 16. This rounds up to 99. So, and this rounds up to 6. So that is why it would be A. Number 4. The function f of x equals negative 5x squared plus 250 can be used to represent the approximate height of an object off the ground after x seconds. Which is the best estimate for the amount of time eclipsed when the object is 120 meters off the ground? So we're going to substitute 120 into our formula and then solve. So I'm going to have f. So we are going to substitute 120 in for f of x and then solve for x. So we're going to have 120 equals negative 5x squared plus 250. Okay, so we're going to subtract 250 from both sides. So 120 minus 250 is negative 130. So we're going to have negative 130 equals negative 5x squared. We need to get the x squared by itself, so I'm going to divide by negative 5. And I'm going to get 26 equals x squared. And how do I get rid of a square? We square root. So I'm going to square root both sides, and I'm going to get x equals, and it will be 5.09. So approximately 5 seconds. Number 5. It says the value of a car depreciates as shown in the table below. Which statements are true? Select all that apply. So we can substitute this data into our regression calculator. And then look at the information that is provided and determine what type of model we should be using and what the equation should be. So let's put in 0 and then 2500. Then we have 1. And 5, 6,000. Remember that we're going to resize to fit the data. This is going to be an exponential regression because it doesn't have a full curve. It doesn't go back up. And then, so it's going down. So let's look. If this is exponential, what is going to be our equation? It's going to be this one right here, A. So A is going to be our equation. So we know it's not going to be B. Okay, let's look at C. C says the function decreases infinitely. Well, yeah, it's going to decrease infinitely. It's going to keep going down forever. And then let's look at D. It says it is reasonable to interpolate to the value of 4.5. So okay, so that means that's going to be within inside the data. Okay, is 4.5 years inside of our data range? Yeah, it's right here. It's in between 4 and 5. So D would be right. And then extrapolate to 40 years. Is it reasonable? No, because if we put 40 years in, the value of the car is already going to be at 0, because this is a real life situation. We wouldn't want to go to 40 years. So that would be no. All right, number 6 says, a convenience store manager noticed the sales of soft drinks are higher on hotter days, so he assembled the data in the table. The function f of x equals 16.4x minus 621.8 models the relationship between x and y, the temperature outside, and the number of cans sold. For what temperature will the model most accurately predict the number of cans sold? So, for something to be most accurately predict, it needs to be an interpolation data. So, it needs to be within inside the data set. So, is 38 within inside the range of our x values? No. Is 47? No. 73. Yes, 73 would be in between 75 and 70. So 73 would be a good temperature to use for a prediction. 96 would not be, because it's not within inside the data set. If you have any questions on this lesson, please feel free to call, email, or message me on Edgenuity.